AutoCAD Mechanical's deflection line calculations. Before starting a deflection line calculation, you must run a moment of inertia calculation to get the results block which contains the data needed for the beam deflection equations listed in the table. Here we have two choices that were run. One for a composite section made up of an unequal length L bracket backed by a rectangular plate, and the other is a calculation run from a hollow rectangular sharp-cornered tube. I'll go to the Calculation panel on the Content tab and select the Deflection Line option. The first thing you're prompted for is to select a moment of inertia block. I will select the one for the composite section. Now indicate the starting point or existing beam. By existing beam, this would be taking the load set from a calculation that has already been run. What I will do here is pick a starting point, and since I want this beam to be 60 inches, I will drag to the right and type in 60. A dialog box comes up, and this dialog box allows you to start adding predefined supports and predefined loads. I'll start with a cantilever support and place it on the left-hand side. I'll place another cantilever on the right-hand side. If you wish to see the graphical display, the button with the 3 right-hand arrows on it allows you to temporarily close the dialog box, change your view of your model, and then go back into the dialog box. So there's the right-hand cantilever. And there's the left-hand cantilever. Press Enter to go back to the dialog box. And now I'll place a floating support in the middle. This is a complex support situation. It can be solved through classical formulas, but it's going to be easier to use Mechanical's tools. Now I'll apply some loads. Let's start with a point load. Place a point load approximately 18 inches from the left. For the rotation angle, I'm going to click up above. And for force, let's make that 1,000 pounds. The units of pound force are being applied because I'm in an English-based drawing that I started from the am_ANSI template file. You could start from a different template file and work in metric units as well. I'll add a distributed load that's going to start approximately 12 inches to the right of the midpoint and continue to about 30 inches to the right of the midpoint. The load is going to be approximately 500 pounds per inch. And if I go back to the graphical display, you can see how I've applied that all the way to the end. Press Enter to go back to the dialog box. And I can also place a moment. I'll place the moment directly over that support. The bending moment in pound force inches. We'll make that 500. And I will edit the distributed load. Let's take that down to 250 pounds per inch. There's also an erase button to allow me to delete that load or any of the supports, and then I could apply a new load using any of the tools shown. The other supports that I have not chosen to use are a fixed in X position support, which would force the beam to stay put and not move laterally. There is a fixed in Y support and a fixed in both. such as a pure pin connection. Next, I would pick the type of material that is going to be used for this beam. I will select the table button, and in this case, I'll use the ANSI materials, and there's a table of available choices. I will select the SAE 1045. That information is put into the two fields in the middle of the dialog box. Or, if you know your specific material properties, you could type in your own values there. When you have fully defined your loading and your supports, you then go to the moments and deflection or deflection buttons to calculate those results. I'll choose moments and deflection. You next have an opportunity to pick what direction the graph is going to be drawn along. Main axis 1, main axis 2, or just the overall results. Whether or not you'd like to have it automatically scale the resulting curve for the results, or if you're going to force a specific number of segments. You can also enter a title. I'll enter rail and press OK. Enter the scale for the bending moment line. Right now, Mechanical's suggesting a scale of 1 to 1094.2. Pick a scale here that's going to be easy to measure later. For instance, I might pick a scale of 1 to 1000. And now I'm prompted for a scale for the deflection line. Again, the default scale is an automatically selected scale, but I can override that with something that might be easier to work with, like 5000 to 1. I now place a resulting block. So we have our bending moment and our deflection line results. And if I zoom in on the result block, you can see that I have information such as a repeat of the cross-section area with a factor of safety. In this case, we're almost at 8 to 1 factor of safety. What these calculations are based on for as far as material properties, and then information such as the maximum deflection in the two directions, as well as the maximum stress.